Well, we have some other questions here, extra questions on completing the squares. Here, for instance, it says, show by completing the squares that the solution to the equation, this equation here is x is -1 or x is a plus b over a. Okay. Let's solve it this way. Okay, this is what we have. Ax squared minus bx minus a equal b. And then we do know that quadratic equation is of the form ax squared plus bx plus c. And then if you complete the square, we're going to get a form of a open bracket x minus p to the power of 2 plus q. Okay, that's the expressions. Quadratic expression and quadratic and the completing the square expression. And we do know also that when we complete the square, we write in the form b over 2 to the power of 2. Obviously, when we get rid of the leading coefficient, the coefficient of x squared. Now, in this question, we're first going to move this negative a over, and then the equation will become ax squared minus bx equal to, I'll leave some spaces for good reason, equal to b plus a, or just say a plus b. Okay, a plus b. Now, I am going to get rid of these coefficients here, a. How am I going to do that? It's when I will divide here by a, divide each term of the equation by a. Now, this, okay, I didn't have to put space here yet. Let's say over a that way. Okay, fine. Now this will become what? A, not a, but x squared minus bx over a equal to a plus b over a. Now, I need to complete the value here, the c value that will make the left-hand side of the equation a perfect squared, okay? Because negative a here, we're not making the perfect squared. So I'll do that by following this formula. I'll say b is negative b over a, so the term with x, okay, the coefficient of the term with x over 2. Now this can be written as negative b over 2a, okay, to the power of 2, of course, and then this makes b over 2a to the power of 2, because when the power is 2, the signs of the base doesn't matter. The base within the bracket doesn't matter. It's still positive, and then this can be written as b squared over 4a squared. Okay. Now I am going to add b over 2a to the power of 2 here, and then I'll add the same quantity on the left, on the right hand side. Okay. So on the right hand side, I don't want to say b over 2a all to the power of 2. I can just say b squared over 4a squared. Okay. Then that's I write this way. We do know that this value is this one makes the left hand side a perfect squared. So we do know this is going to be like to the power of 2, like that, and there is going to be x, and then we're going to use the sign of the middle term, so negative, and then what? B over 2a equal to what? Equal to a plus b over a plus b squared over 4a squared. Now, on the right hand side, I need to write everything with a common denominator. So I must times here by 4a, okay, and times there also by 4a. I times it by 4a. So now this will become 4a times a, that makes 4a squared. 4a times b makes 4ab, and then plus b squared all over 4a. Okay. When I look at this numerator here on the right hand side, we can factorize that. I'm gonna write it here in yellow. Look here, 4a squared plus 4ab plus b squared. I can solve this by factorization. So I'll do 4 times the coefficient here is 1, right? So it makes like 4, and the factors of 4 are 1 and 4, 2 and 2. So if I need to get the coefficient of the middle term, 4, I can only do that with 2 and 2. So then this can be rewritten as 4a squared. Instead of me writing 4ab, I write plus 2ab plus 2ab, and then plus b squared. Okay, so we can factorize here. I can take 2a for common factor there, and there we can take 2b for common factor. So this will be if I take 2a for common factor, it's going to be like 2a plus b, and there it's going to be 2a plus b also. Now we have like 2a plus b, factors of 2a plus b, which is just 2a plus b to the power of 2. So this is 2a plus b to the power of 2 all over 4a squared is also 2a to the power of 2. Okay. Now, because they're both to the power of 2, we can write it like 2a plus b over 2a to the power of 2. Okay. And then there we have like x minus b over 2a to the power of 2. Now that the basis, the exponents are common like this, we can just simplify, cross exponents, okay, and then equate the basis. So this means x minus b over 2a equal to 2a plus b over 2a. So now if I need to find, actually, we need to be careful here. When I cross this, it's because we square root here, we square root there, okay? When we simplify like that within the equation, over here, the answer is always plus minus, okay? It's plus minus. Now we can move b, negative b to a over, it becomes positive b over 2a plus minus 2a plus b over 2a, okay? So the denominator here are also common, so we can combine them. That makes x is equal to b plus minus 2a plus b all over 2a. There are 2 solutions here. The one solution goes with the positive, so b plus 2a plus b makes 2a plus 2b over 2a. So we can take 2 out for common factor. Can move it like this. If 2 is the common factor, because it is, it's going to be like a plus b over 2, and then we can simplify. Actually 2a. We can simplify 2 and 2, and then the answer is just a plus b over a. Okay, on the other side, x, if we use the negative, we have like b minus 2a minus b. Careful here, because the minus is, I should have put brackets here. Yes. Okay, it's the minus, the whole thing is like, we have like b minus 2a minus b. So all over 2a, and then here b minus b falls, and then we have left with negative 2a over 2a, which is just a negative 1. So those are the 2 solutions, okay? What we have proven, this is what we had to prove. X is equal to a plus b over a, x is equal to negative 1. These are the solutions that we see there. X negative 1 or x is equal to a plus b over a. Thank you. We had a question like this, but this time the question says, show by completing the square that the equation has no real solutions. Previously, we had to solve this by completing the square to show that this is always positive, and now the question says it has no real solution. Now, okay, we have x squared plus x plus 1, okay? I'll recall, quadratic equations are ax squared plus bx plus c. This is the form of quadratic equations. And then to complete the square, it's when we write in the form, this form a open bracket x minus p to the power of 2 plus q. And then we need to make c equal to b over 2 to the power of 2, obviously when the coefficient here is just 1, okay? So in this case, our b is just 1, okay? The coefficient of x, b, is 1. So we can substitute there. It's going to be like 1 over 2 to the power of 2, which is a quarter. Now, we can work out this x squared plus 1x plus 1 equals 0. To solve this by computing the square, I'll move this 1 over, okay? I'll move the 1 over, and then this will become what? X squared plus x equal to -1. So we can write x squared plus x, I'll leave space there. I'll write here -1, and then over here I'll say plus a half to the 2. Okay, there also I'll plus a half to the 2, which is just a quarter. Then over here we can just select the bases, okay? So this will be x plus a half to the power of 2 equal to -1 plus a quarter is equal to -3 quarters, okay? So -3 quarters. Then to solve for x is when we will going to square root both sides. So if I square root here, I must also square root there. Square roots, we cancel the power of 2, and then this will make x plus a half equal to plus minus square root of -3 quarters. But now this part here is the problem, okay? Square root of negative number does not exist. So here we say no real solution. No real solution. Okay. The question says here, by completing the square, show that the solutions of any quadratic equations of the form, this form, where a is different than 0, can be determined by the formula that we see here. This is called the quadratic formula. Okay. Okay. Now I want to write here the equation is ax squared plus bx plus c equals 0. Now I am going to move the c over. So this will be ax squared plus bx equal to -c. I want to get rid of the coefficient of a squared, okay? And then this will be x squared plus b over a x equal to -c. I'll say equal to -c over a. I'll leave this space for good reason. We did say that the c, after that we get rid of the coefficients of x squared a, okay, it will be expressed by b over a, okay? And then quadratic equations, as we know, it's ax squared, excuse me, it is as expressed here. This is the quadratic equation. Now I need to change c to this form, okay? This is the form that will make my left hand side of the equation a perfect squared. In this case, my b is b over a, so it's going to be like b over a all over a to the power of 2, okay? And then this will become b over a squared what am I saying? Sorry, I meant 2 here. Okay, there's 2. So so over here it's gonna be b over 2a to the power of 2, which is b squared minus 4a squared. Okay, then I will add this on the left and on the right hand side, b squared 4a squared, and then I add also there b squared 4a squared. Okay, now okay, this side I prefer just to write I prefer to write it this way: b over 2a to the power of 2. Okay, then I will take only the basis. I'll take the basis here. It will be like to the power of 2, and then the sign of the middle term. That's going to be like x, and that's going to be b over 2a equal to I can reverse this order: b squared over 4a squared minus c over a. Now, to work it out, I will times here by 4a, I times here also by 4a. And then this will be what? B squared minus 4ac all over 4a squared. There we have what? X plus b over 2a raised to the power of 2. Okay, we're going to solve this. We can simplify this. Okay, when I reduce this, say it's square root of this and then square root of that. Now this square root we cancel the power of 2. Okay, and then that makes what? X plus b over 2a equal to that makes plus minus b squared minus 4ac all over remember when we square root both sides here, this is going to be square root of the numerator and square root of the denominator here, which will be just 2a. Okay, now if we move this part here to the other side of the equation, this will be x equal to minus b over 2a plus minus b squared minus 4ac all over 2a. Okay, now the fact that the denominator are common, we can just write like minus b plus minus okay, square root here, sorry. I say we square root the numerator and square the denominator. Okay, if this is going to be square root there, and then the square root of the denominator will make 2a. So this will be square root of b squared minus 4ac all over 2a. Okay, and that's the solution of the quadratic equation as given here. Minus b plus minus square root of b squared minus 4ac over 2a. Here it is. Thank you.